Recall the fundamental equation for calorimetry. The heat energy, Q, absorbed by the water in a calorimeter is calculated using the formula. Q equals mc delta T, where m is the mass of the water, C is the specific heat capacity of water, 4.2 J/G times degrees C, and delta T is the change in the water's temperature. Calculate the heat released by the combustion of the cashew sample. Mass of water, m, equals 1000. G temperature change, delta T, equals 25.0 degrees Celsius. 20.0 degrees Celsius equals 5.0 degrees Celsius heat absorbed by the water, Q cashew. Q equals 1000 G times 4.2 J/G times degrees C times 5.0 degrees Celsius equals 21,000 J equals 21 kilojoules. Since this energy was produced by burning exactly 1.0 grams of cashew, the energy content per gram of cashew is energy content of cashew equals 21 kilojoules over 1.0 grams equals 21 kilojoules/G. Calculate the heat released by the combustion of the marshmallow sample. Mass of water, m, equals 2000. G temperature change, delta T, equals 30.0 degrees Celsius. 25.0 degrees Celsius equals 5.0 degrees Celsius heat absorbed by the water, Q marshmallow. Q equals 2000 G times 4.2 J/G times degrees C times 5.0 degrees Celsius equals 42,000 J equals 42 kilojoules. Since this energy was produced by burning 3.0 grams of marshmallow. Calculate the energy content per gram. Energy content of marshmallow equals 42 kilojoules over 3.0 grams equals 14 kilojoules/G. Compare the energy released per gram of each substance. 1.0 grams of cashew releases 21 kilojoules of energy. 1.0 grams of marshmallow releases 14 kilojoules of energy. Comparing these values, the combustion of 1.0 grams of cashew releases more energy than the combustion of 1.0 grams of marshmallow. 21 kilojoules/G greater than 14 kilojoules/G, which confirms option C is the correct answer. The correct answer is option C. The combustion of 1.0 grams of cashew releases more energy than the combustion of 1.0 grams of marshmallow.